You actually have to start thinking about ACID. You actually have to start thinking about security, privacy, concurrency, scalability. And before you know it, you would then have invented a database.
Welcome to Coding Chats, Richmond. Great to have you here. Love to talk about AI today, in particular, AI and memory. So what is memory in terms of AI and AI agents?
Yeah, thanks for having me on this, John. I'm very excited to be on Coding Chat. So what is AI memory in AI agents? And when we say AI memory, we mean agent memory. So let me give a good definition. Start at a high level. Agent memory is basically the concept on how AI agents remember, right? Almost similar to the way humans remember information. The simple way to understand it is agent memory is how agents remember and adapt to new information. So we can take it another level deeper. We get technical. We then define agent memory as the composition of all the system components of an AI infrastructure that holds data and also retrieves data and transforms data. So when you look at an agentic system, the components of your system that does that are your embedding model, because that takes in data, encodes it, and gives you a numerical representation. Then you also have your LLM, which takes in data, tokenize it, gives you like some completion, some tokens as its response. Then you have re-ranking models in some architecture as well, which is almost similar to embedded model. Then you have your database. So all of those system components, they hold data and they transmit data between them to enable your AI agents to learn and adapt in real time.
Okay, cool. So thinking about a lot of my audience that might be familiar with Claude Code or maybe Claude Cowork or Codex and so on, do those things have a memory in the way that they're thinking of or not?
Yeah, so now they do. It never used to be that way. So Claude Code and Codex and let's just say OpenAI and Anthropic, they're very focused on solving memory in very big ways. They have dedicated teams that focus on AI memory and personalization, and they have probably very different approaches, right? Because the fun bit about memory is it's not standardized, which means there isn't one way to do memory. There are different ways to approach it, and it allows for a lot of creativity. So at the moment, when I use any of OpenAI's product, they both have memories. They have session memory, so you can use information from one thread in another thread. It remembers, and it never used to be that way. Maybe 6 months to a year ago. But that just shows the evolution of how these companies are discovering more applications of memory within AI use cases. So yes, they do have memory. Claude Code is another one of Anthropic's flagship product. It has memory built in. It remembers your preferences. They have different ways to feed information, which is memory, into the models to allow for a better coding agent, right? Particularly in Claude Code. And in other of their products, they have memory incorporated as well.
Okay, so when I looked through Claude Code earlier today, some of their memory seems to be very much file system based. So it's basically checking out what it remembers to a file, being able to reread that and keep appending that, particularly with sub-agents.
Yes.
What are your thoughts on using the file system memory? What are the weaknesses? What are the strengths? And you mentioned database a few times. So
yeah.
Which should you use?
Spoiler, I work in a database company. So I'm a director of AI developer experience at Oracle, and at Oracle within a database division. So my focus is all on the database and trying to educate AI developers on how they can use their database, our database, to actually build production ready, secure, and safe modern AI application. So if you're looking at Claude Code today, you're seeing that it's using file systems to store information and access information within the current execution context. So that is the paradigm that we see a lot of people adopting, especially when they're going through this POC stage. But there is another aspect to this, which is even behind Claude Code, there is memory, there is some form of memory aspect ongoing behind the inference API, right? So you see what you have, what you within your execution context, within your IDEs, you have this, what I don't want to say temporary memory, but it's the one that you are exposed to, memory that you as the user are exposed to, and so is the LLM. But behind the inference, right, you actually have the LLM, and you have an infrastructure where information is going into Anthropic's infra, and they're actually using some of this information to allow subsequent calls to be more performant. For example, when you summarize context in Cloud Code, it is not stored in the file system, right? You can't see the summarization. That actually gets stored over an Anthropic's infrastructure. Then that goes and there's a retrieval whenever it needs to reference. Does that make sense?
Okay, cool. So you touched on a few reasons why a database versus file might be good. So to go that back for any software engineer sitting here thinking, well, I've got to build an agent. Let's say I work in a large travel company, for example. I've got to build an agent that's going to deal with customers. The agent's going to sit on the website. Somebody comes along and talks to it. Why do I want memory in that? And how, would I choose a file system or a database? What are the trade-offs I'm making?
Yeah. So there are two questions there. Why do you want memory in your application? And especially one that you have consumers interacting with some chat interface. Then the second question is, why would you want a file system over a database or vice versa? So I'll take on the first question. Me and you are interacting, and we're having a good interaction, I would say. And you told me what the name of your podcast is. You told me what your name is, John, and we're on the Code and Chat podcast. Now, imagine if 5 minutes later I forgot who you were and I forgot what we were doing here. That would be a very bad podcast experience for both you and your listeners, right?
It sounds like my normal morning.
But now the same applies to our AI application. When a user today interacts with any software that even remotely calls itself AI enabled or AI first, they expect continuity in interaction, right? So when a customer comes to your travel website, because that's the example we're using, and the customer says, I would like to go to Tokyo, very popular holiday destination. Then let's say the customer goes away and they have to do something in their life, and they come back and they have to start again with the agent and tell them all the travel preferences and like and dislike. That can get annoying really quick. That's a bad experience. You will lose your customer. That's why memory is important. That's why remembering is important. The same way we want to have good human experiences is the same way we want to have good agent experiences. And memory is a key component of it. Now, to answer your second question, file system versus databases. So in this world of memory, there are different substrates and different components that can hold information. You can hold information in a database. You can hold information in a file system that is very loose. And one thing I'm seeing in the space is people are more advocating for file system, and the reason is this: it's quick. It's quick to actually tell the agent to store information into a file. You'd have to worry about schemas. You'd have to worry about retrieval mechanisms and whatnot. I think you want to say something to that, right?
Yeah. Well, it's chucking out text, isn't it?
Yeah.
It's spewing out text. It's really easy to write that text to a file.
Yeah, exactly. But do you know what comes at a cost of that speed? Security, scale, right? Because when you start to go into production and you start to realize that you have this high throughput to your actual servers, and you have multiple customers trying to save data, or even multiple users trying to save information into one file, you start to think about, okay, I need to lock the file, then just so you can actually don't have conflict of information, right? Okay, I need to make all the transactions atomic, right? You actually have to start thinking about ACID. You actually have to start thinking about security, privacy, concurrency, scalability, and before you know it, you would then have invented a database, because database started off from there. So Oracle has been around for decades, longer than I've been alive, so for decades. And Oracle has been in the data management business for a very long time. And we have understood what it takes to really build efficient, secure data storage for application in any era. I literally mean any era. So Oracle was there in the internet era, we were there in the data era, and we're here in the AI era doing what we do best, data management. And what that means today is we handle agent memory really well.
Yeah, you're right. I mean, I was building stuff on Oracle for websites in 1996 with Perl. So Oracle has now built out an AI database. So what's changed? What makes it an AI database versus the Oracle I used in 1996, which I appreciate has moved on in a lot of other ways since 1996. But what makes it an AI database versus we were all talking about relational databases then?
Yeah, that's a good question, John. So one thing, very quickly, Oracle has realized the needs of modern application in different eras, like I've said. Wherever era it is, we realize the need, but we've also realized the a very strong need to reduce the cognitive load of our developers, which is we don't want our developers to start thinking of multiple databases whenever they need to start handling different data types. So with Oracle, you use one database for all your data types. Just wanted to mention that. But the AI capability is very important, especially in this era. Oracle, with using an Oracle database, you can have an embedded model. Remember those components I said that handle memory? You can have an embedded model in your database. What does that mean? It means your developers don't have to start worrying about embedded model selection. They don't have to worry about the code that they use to actually load the embedding and actually generate the vector embeddings themselves, right? You don't have to worry about the code to load the embedded models and generate you can just select or load in an embedded model in the database and it takes care of it for you. We are reducing the cognitive load of AI developers that are building AI applications by taking away all the concerns that are data related and bringing it into capabilities of the database.
So rather than me having to build a pipeline that's going through the embedding model and then storing that somewhere, I can just throw my text at Oracle and you'll take care of it if I've configured the right embedding model.
Exactly. You get the embeddings straight into the role and you don't need to then get another database to handle vector data, get another database to handle knowledge graph, get another database to handle JSON. You just have a single database engine to meet the heterogeneous nature of data in the world today.
Nice. So let's turn that around a little bit because Oracle was the database of choice for large scale and for enterprises back in 1996. There wasn't really a serious alternative. Then Microsoft came on with SQL Server and maybe took a little bit of the lower end market because Oracle was perceived as the enterprise solution, the serious solution, and SQL Server was a cheaper competitive. And then we started to get more open source with MySQL and Postgres. Where does Oracle still fit in that? Have you expanded the offering then? So let's say I'm coming along, it's me and my small business. I want a database. Can I grab Oracle or is it still really for the enterprise big boys?
Oracle is definitely present in all of the paradigm shifts we've seen happen in technology and realize that we need to meet developers where they are. So if you are a developer today building an AI application, you can spin up an Oracle database for free.
Awesome.
Right? You can spin up an Oracle database for free. You don't have to be like a large enterprise customer spending millions, even though we do handle that because about 95 to 97% of Fortune 100 companies have the data sitting on Oracle. Oracle is a custodian of enterprise data. But we also realize that we need to meet developers where they are. So you can install an Oracle database, 26AI at this moment that we're talking, through Docker on your local machine. Or you can get a free instance on Oracle Cloud. But we are meeting everyone that is building AI application where they are.
That's really awesome. You need to talk about that more because I've followed Oracle for years and I did not know that. So that's really cool to know.
It's definitely, Oracle is definitely evolving and will continuously evolve. And that's what's keep Oracle going for decades, right? There are loads of companies that have emerged in all of this inflection points that has happened, right? And loads of companies have gone as well. But we are still here because we understand the change that's happening at a very intimate level. And we're constantly evolving. We're not stopping. So you're going to hear more about what Oracle is doing in AI, like you're hearing now, like your audience is hearing now. And you're going to be like, Richmond, you're probably doing too much. But yeah, that's my aim. So yeah, you're gonna hear more.
All right, cool. And talking of more, we talked about memory a little bit earlier. I saw on LinkedIn that you've been posting for close to 100 days, I think, about memory. Why are you so passionate about memory at the moment? What's really driving that?
Memory is one of the most easiest concepts that I've found that a lot of people are able to understand whenever I speak about AI. So I studied AI master's level. We did computer vision, deep learning, and space robotics. My mom didn't know what that was about. And honestly, she probably didn't care. She's like, oh yeah, you got a master's, yeah, cool. And she doesn't care what that's about. If I'm talking about convolutional neural networks and how I'm getting training data and the data augmentation techniques in the model, and we're doing transfer learning, and they don't care. But when I tell my mom that in my job, I get to make software mimic the way human remember, right? Human memory. She gets it to an extent. Even my grandma gets it. Anyone can get agent memory because memory is universal in some cases. Some people's memory are like, hey, do you actually have where some people you encounter you would question if they have a very good memory. But in most cases, memory and the understanding of it is universal. And the beauty of it, which is also a disadvantage, is in humans, it is not solved. We don't even know how our memory, both in your brain and in mine, we don't fully know how it works. It's an active area of neuroscience, and it's an active area of computer science. So we find this, and it's nothing unique. It's happened before, but we find this pattern of where in technology we borrow from biology to build systems that really blow our minds in terms of performance. So for example, the early scientists and mechanical engineers and inventors that tried to build vehicles of flight were heavily inspired by animals of flight. But today we don't have planes flapping their wings, do we? But we have vehicles of flights that are moving at crazy speed that will probably make like an eagle jealous, I'd guess. But the key thing for me is this, right? Memory. Why memory? It's easy to understand. It's easy to explain. But I can also go deep if I need to with my technical audience, right? We can talk about how memory is represented within the different system components I've spoken about. But we can also talk about a very high level about short-term, long-term memory, semantic and episodic, without going into the details, and I can just carry everyone along. So that's why it's agent memory.
Well, you just go a slightly different thread there. You mentioned computer vision and you studied that. I think that's a really interesting idea that certainly seemed to be like quite high in deep learning about 10 years ago. A lot of people are very focused on that. We had a lot of people looking at ImageNet and building models around that, and there's a lot of focus on convolutional deep learning networks. Hardly see anyone mentioning that these days. So how do you feel about moving your focus from computer vision to LLMs, and what do you find as the differences and similarities? Because ultimately they're both deep learning networks.
Yeah, so people are still very focused on computer vision today, right? There are transformers model being applied to computer vision techniques, right? Or computer vision problems. The transformers apply themselves well to it. And there's some people that are still exploring using convolutional neural networks as well. Computer vision is still an active area of research. It's still a fun research area. And again, computer vision is also easy to understand, right? we're trying to teach computers how to see. You can start to understand it. And if you actually look at the way convolutional neural networks actually work, the early creators of it or researchers actually got another inspiration from neuroscience, right? One of the first famous computer vision networks was Lenet 5. He had like 5 layers. Today we go, I don't know how many layers we have in transformers and even the really deep neural networks. I don't even know how many layers we're going, but it was just 5 layers. And one of the key findings within the early days of computer vision and deep learning was they got inspiration from neuroscience, and they found that neurons within the layers, whenever they were activated together, right? Neurons are wired together, fire together. That saying comes from neuroscience. It actually comes from an experiment done by folks that won a Nobel Peace Prize, Hubble and Wiesel. I think I'm butchering the name there. But they were actually observing visual stimuli and how cats respond to visual stimulus, right? And they were trying to map the visual cortex of a cat because it was similar to the way a human works. And they came up with a lot of findings that inspired what we saw in convolutional neural networks or early neural networks. But computer vision still has a place today. CNNs, convolutional neural networks, still has a place today. There is vision in transformers approaches, right? That people are still trying to solve today. So yeah, I still feel like it's an active area of research. The reason why I would say that I've moved away from that realm of AI is very broad, right? The reason why I've moved from that realm is it's by chance, right? I was a computer vision engineer at a London-based startup for a few years. Then I went into consulting, and I worked for a large consulting company as a machine learning architect, mainly focused on the computer vision projects there. Then I got reached out by MongoDB at the time, and they asked if I wanted to just help them get into the AI communities and get some AI developers along, because while I was a computer vision engineer and a machine learning architect, I always educated AI developers through writing on Medium or speaking or doing courses and teaching. I wrote on NVIDIA. I wrote on popular machine learning companies at the time for their blogs. So they just said, "Hey, do you want to do this as a job?" I didn't know developer advocacy or relations was a thing, right? So that's how I found myself on this track. And John, it works. It really works, because one thing I tell folks that are trying to get into this AI space, and I say it's there's a lot going on. What do I pick? I say pick anything. You can pick any field of AI. Eventually, all paths are going to converge into where we're trying to get to as a whole society, as mankind, right? So you could start off in computer vision and you probably end up where we are today, or you could have started off in NLP and you'd have ended up in where we are today in some shape or form.
That's true. And the last time I shipped an AI product, it was built around evolutionary algorithms. And again, that now, I think Google are doing some research on using evolutionary algorithms and pulling in Lisp and using that to do genetic programming with an LLM to generate some starter code, and then the genetic programming to do the crossover and mutation to generate new programs that way. So even genetic programming, which was almost impossible to do 35 years ago when I first came across it, because computers were too slow, it's now having this resurgence around LLMs. And as you say, it's converging into LLMs.
Yeah. And it might not be LLMs that will be the architecture that we settle on, because there are other researchers, prominent ones, that are exploring other architectures to actually build better models.
Yeah, absolutely. And let's face it, Transformers didn't start off for this. They started off with a completely different purpose.
Educate me.
So Transformers were literally part of doing translations, as I understand it. They were looking at where to encode from, say, English to French. And it was only when they changed it with the attention mechanism that we end up with text generation.
Yeah. And back in the day, I say back in the day, I'm not that old, but for solving those type of natural language task, we used to use recurrent neural networks or LSTMs, and obviously those had their problems, such as like obviously the more you train, the less in the earlier training data were probably suppressed, and the RNNs, recurrent neural networks, were actually forgetting earlier training. You still have that problems with LLMs today as well. It's called catastrophic forgetting. We still have that problem today with LLMs, but with recurrent neural networks, it was massive, and it stopped them from being massively useful.
I think the other problem, when I last looked at recurrent neural networks, must have been about 2014, 2015, because we didn't have, I mean, CUDA was fairly new then. People hadn't really figured out how to do a lot of training. GPUs were not as powerful as today, so your training sets were massively smaller. So I remember seeing a good demo of recurrent neural network for text generation, and it was doing a really good job of generating real words, not gibberish, but it was doing it letter by letter. So the fact that you got words was great, but it didn't always make sense as sentences because that wasn't that connection between the different words, where obviously now we're dealing with tokens and we've got attention mechanism. They're coherent rather than gibberish, but it was still quite impressive to see at the time, and amazing that you could get that out of such a small training set.
It really was. One of my projects, like pet projects, was to automatically generate caption for Instagram pictures using recurrent neural networks, and it worked relatively well, right? Obviously, you have to scrape a bunch of training data and nothing to what we see today, right? You can just zero shot a caption for an image, but back then you had to give it a lot of training data to even perform relatively well. But yeah, the field has come a long way, and yet we still have a long way to go.
Yeah, absolutely. So what's your feeling on AGI then? There are a lot of people promising we'll have AGI in the next couple of years. I'm hand on heart, complete skeptic on that. I think we're decades away. What are your thoughts?
Well, I don't really think about AGI as much as maybe other people might think about AGI. And that's because the definition of AGI generally just changes depending on who you talk to, or depending on what era we're in, or depending on what capabilities we have with AI today. Because we keep moving the goalpost, right? So, what would you define as AGI?
That's a good point. So, to my mind, something that would qualify for AGI when I first started looking at AI and being interested in it was something that could do everything that a human could. So, rationalize things, be sentient, and make decisions based on information and input from the environment. So I would disqualify an LLM from ever being able to achieve that because it's only got text. It has no feeling in the world. It has no sense of spatial awareness or so on. It's dealing with a stream of tokens and outputting a stream of tokens. Again, I would say it's not sentient because it can't decide to do anything on its own. Ultimately, an LLM is a function. If we simplify it down to the ultimate, we are calling this function, passing in a bunch of tokens, and it's generating a bunch of tokens out the other side. I think to qualify as AGI or super intelligence or whatever, something's got to be sentient and always learning, sensing its environment, and then making some decisions based on whatever it, what's the right word, feels, intuits about the world around it.
And with your definition, there is this line that has to be crossed by computational system in terms of them being sentient, right? But because all what you say about an LLM not being able to perceive its environment is not entirely true, because it can perceive its environment, right? There are many experiments where you've put a lot of agents that have an LLM that enables cognition abilities, and you put them in a simulated environment, and they can interact with that environment and act upon the environment. So we do have that today, but it's probably not you probably want something that feels human.
Well, the only input they've got about the environment is any stream of tokens that we can pass in. So the worlds have got to be encoded for them in that respect.
But isn't the world encoded for humans as well?
Probably. I mean, we are taking some input from our eyes, our ears, our feel.
And it's encoded into electrical signals.
Yeah.
So it's could be the same, right? That's what I'm trying to say. That it really depends on who you speak to when you talk about AGI, right? Humans do have the visual images that we process. We're actually not. Our brain is doing a lot of filtering in terms of the visual images we're processing, and it's been encoded and it's just electrical signals that work really well, right? Biology is amazing. Nature is the best architect of intelligence. Um, but LLMs are also encoding information that we're feeding, whether images, video, or environment sensors data, and they encode it into numerical formats and they do computation with that. And you have next token prediction that mimics intelligence.
Yeah, but it's mimicking it really rather than having any further understanding of that.
Yeah. So that's the key thing that is missing. I think that's the key thing that is missing where people feel like they need to explore other areas or other architectures of to create models, and they're folks looking into world models, and because the mimicry itself is it feels like a cheap version. But remember what I said at the beginning, which is planes don't flap their wings.
That is true. That's true. But again, it depends what people want from it. I mean, one of the things that I object to with the idea that some people think that LLMs are intelligent is that they're not sentient. They don't have this understanding of the world. That also doesn't distract from them being useful, doesn't distract from them being a useful tool. Coming back to your analogy, a plane doesn't flap its wings. It still flies. It still gets us from A to B much quicker than us trying to walk across the ocean or go across it. So they can still be useful and have a lot of benefit without necessarily having that. And I think that the biggest problem I have with people trying to talk about LLMs being intelligent is we put more faith in them than they do. We start talking about having to make critical decisions and doing medical diagnosis or being in charge of weapon systems. And when they're not sentient, not able to make decisions with a concept of the world and with an understanding, that kind of scares me.
It does. And we hear this a lot, right, from our customers. In AI adoption, we see the way that AI is adopted amongst developers is very quick, right? Developers are very quick to experiment. MCP, we jumped on it with all the security flaws. We don't care. OpenClaw, yes, give us some of that. Security flaws, yeah, we don't care. But when you start to work in mission critical systems, and where your product affects millions of people in terms of financial decision or health decisions, you start to think very carefully about what you're putting out there and adopting in terms of the innovation we're seeing today. So we have that. We see that at Oracle. And that's why, like I said, Oracle is the custodian of enterprise data. And we also are trying to really meet the demands of startups in terms of innovation. And that's why safety and security is one of the most important things that we keep top of mind in every single product we put out there. We understand that a lot of people are looking for building secure infrastructure and building this AI application on secure infrastructure. And because Oracle has seen the nature of data change, the nature of the regulation around data change, we've created systems to meet robust data requirements, privacy requirements, security requirements in different regions. So security is our business.
So on that note, let me pull it out a little bit. Let's say I've got this chatbot that's bringing in stuff. You said we can dump the text straight to Oracle and you'll do the embedding. How do I introduce handling PII in that? So, another system, I might have a privacy vault. I might be going through and tokenizing some of the data. That then is removing a little bit of the value of what's in that message, potentially, if I pull out that PII before I embed it. How do you cope with that? Do you do the tokenization before putting the stuff into the database and then embed the tokens for my privacy vault? Or do you handle that within Oracle as well?
Yeah, that's a good question. So, and to answer that, because you have your embedding in the database, which has the enterprise grade security that you want, you don't need to, your data is not leaving the database. So you can use the embedding and get all the data into the embedding and out. But that data is not leaving your infrastructure because the embedding is in it. You're not going to like an inference provider, sending the tokens to sending your data to the cloud, and getting the numerical representation back. No, your embedding is in the database.
So your embedding's staying with you, but what about if you've got a global customer base? How are you managing the data sovereignty there? And also, how do you manage, that data is there, so the access control. So,
Yeah.
If I come along and I'm accessing, a pretend travel agent and it's me, John, accessing it, how do you make sure it's only me, John, that sees my embeddings versus, I know,
Yeah.
Steve from
So
down the road?
even in the age of AI, the data security that we apply, that we've been applying for decades and working on, are relevant now. So fine grained access control is in the Oracle AI database, right? So you can set the level of access any user within your database has to any of the data, and you can actually transfer this into the agents particularly as well. So that is, again, it's, I know AI feels new. It's still data. It's still the business that I said Oracle have been doing for decades. Data management. This is our business.
As you say, it's what you've been doing for decades, but a lot of people are still, as you say, gone back to that text and they're using text and rediscovering this whole need for, we actually need a database. What do we need the database to do? And so we've got a whole bunch of, new developers or people tackling new problems they haven't tackled before, rediscovering that need. And, it's this interesting stat from a couple of different surveys about developers that the average developer has less than 10 years experience with an industry that's grown very, very fast. So most people are kind of still relatively new to this job and what they're doing. So they're not remembering stuff that we did in 1996 because,
You are
as you say,
absolutely correct. You are absolutely correct. There are new developers, new builders, and new people experimenting with AI. And that's why you see folks like myself in Oracle, right? We have very fresh talent, very educated talent that are in the front lines, that are in the developer community, doing the research and always making sure that Oracle is always evolving and meeting the needs, but also educating as well, right? Because we understand there's new developers that are coming into this space and we have to bring the same message and obviously repackage it in a way that they understand today. Because at the same time, I might be saying agent memory. If I was born maybe 20 years ago, I'll just tell you, hey, it's all data, right? Because agent memory is data. But we're using the word agent memory because we understand that there's a new paradigm of how people are understanding how data and information is seen within the context of an agentic system. And that is memory. And that's how we communicate to our developers today. And that's how we give the solutions and all the notebooks and technical assets. We introduce it through this new lens. So like I said, we will always meet developers where they are.
Awesome. So talking about educating then, Oracle's doing a data day in London next week, which will probably be last week or two by the time this podcast comes out. What other educational resources do you have that developers can find to learn about agents, learn about memory, learn about how to leverage Oracle's database and tools to build agents?
It's always weird when I say this, but our team is so hard at work that I can say this confidently. We will find you, right? If you're in AI, you're going to see some Oracle technical assets just flying through your feed somewhere. But for those who can't wait, and you shouldn't wait, we have the Oracle AI Developer Hub, which is a GitHub repository where we put all our technical assets related to AI that we see today. So you see the link in the show notes. We have the Oracle Developer Resource page on oracle.com. And we update this with all the events that our team is going to be, all what we're doing to meet developers. We are in probably most of the top AI conferences.
right, that are happening in the Bay Area, happening in London, because we are, like I said, we're in the front lines of this. So you can see the team on LinkedIn. You can see us on oracle.com. You can see us at a conference near you. We will find you. But the links are in the show notes for those who can't wait.
Awesome. And then what top 3 technologies, apart from Oracle AI Database, would you say that somebody should learn if they want to be building agents effectively?
I think sandbox providers, which Oracle is a sandbox provider as well, are very important in this age where you have LLMs that can generate code and you need a secure environment to execute this code. Or you have external resources that are providing you with some form of execution capabilities through MCPs, but you still need to actually do that in a secure environment. So sandboxes are very important to learn. At the moment as we're talking, I know Langchain, they launched a sandbox within Langsmith, right? Pydantic, they have their own sandbox. Box have their own sandbox. It's a very relevant component within the agent stack. And again, Oracle, we meet developers where they are, so we have our sandbox offering as well in Graph VM.
Okay, cool. So sandbox.
Sandboxes. I'm trying to think very, very hard about this because the technology. When you say technology, I almost want to think about hardware components or architecture components. But one of the key things that we're seeing in the space today is the real moat, and what people need to understand is everything that goes around the LLM, which we define today as the harness. That in itself is becoming a unique area of study for agent engineers or AI engineers. So, for example, Manus, they got acquired by Meta late at the end of 2025. And Manus is a company that really understood how to build systems around LLMs that really get work done, right? They had a very good harness for handling context and for ensuring there's continuity in long horizon tasks. And they publicized a lot of the learnings, and they're one of the teams or one of the key folks that were pushing the boundaries of agent engineering. So it's not a technology, but how software is developed. That's another thing developers need to learn. So first one was sandbox. The next one is agent harness. Not really a technology, but it's a little bit loosey. So let me think of the third one. I can't say the database, right?
You can say the database if you want, but that's
Yeah,
kind of a given.
I think the database, it is a given because you need to store information, retrieve information, and do that efficiently. And I think that's very important. It's so important that I started coining the term memory engineers, right? Because, like I said, like you said, actually, people keep rediscovering things that have existed. So what's happened is a lot of developers that are new in this agentic era, they come into this space and they don't know what we've done in the past or what has been done by engineers before us in the past. And what I mean by that is there were a lot of really clever people trying to solve information retrieval for decades. There were a lot of people that were trying to solve database engineering and retrieval optimization and search optimization for decades. But now we're seeing AI engineers just coming in and say, "Oh yeah, vector search is all you need, man." It's like, no, you don't. You need all of this components that we've been working on for decades that actually make your retrieval pipeline accurate and optimized for real-time scenarios or mission critical workloads. Because accuracy is actually very important. And we've been doing that for decades. So I find the need to actually coin a new kind of discipline that developers understand today, but borrows from the techniques of yesterdays and the giants before us. And I call it memory engineering, right? I'm educating tomorrow's AI memory engineer. And memory engineering is just a discipline that's a cross section between data engineering, search optimization, agents engineering, and all the good stuff we've done in information retrieval.
Very cool. And you recently said that they are the unsung heroes of AI product landscape.
Yes, they are, because I do feel like they are the unsung heroes, because you were just talking about Claude Code at the beginning of this conversation, and you were talking about how Claude Code memory works, and there's a team responsible for that, and it's so important, right? Like the travel assistant that just keeps forgetting what holiday destination. How annoying would it be if every time you were interacting with Claude Code, it forgot your code base, or there wasn't a mechanism for it to remember? Those are the memory engineers. They are the unsung heroes, right? Cursor, they used to have just one person working on memory, and he titled himself memory engineer, right? And I'm sure that the team is massive now. OpenAI, they have a personalization team and a memory team. So it's a real thing, and memory is one of those things that if it works, you're like, okay, it's meant to work. But when it doesn't work, all hell breaks loose.
Yeah, one of those things you notice if it's not there.
Exactly. Unsung heroes, I tell you.
Excellent. Awesome. Thanks very much, Richmond. If anyone wants to get in touch, where can they best find you?
I'm not going to say I'll find you. That would be very... Um, you can find me on LinkedIn, Richmond Alake on LinkedIn, but you can also follow Oracle Developer on all our social channels. We are on LinkedIn, Oracle Developer on LinkedIn and on Twitter or X, so on Instagram as well. So yeah, you'll probably find me there, or you can follow me on LinkedIn.
Awesome. We'll put some links in the show notes as well.
Excellent.
It's been a pleasure, Richmond. Thank you very much for your time today.
This has been a very good conversation. I'm very glad we had this.
Thank you. I hope you enjoyed that episode of Coding Chats. If you did, please like and subscribe. And feel free to check out these other videos on a similar topic.